Hello everyone, welcome back to my channel. So in this video we will solve two problems regarding the special case 2 which we have discussed in the previous video. Okay, so if you have not seen that video, please go there. I have told in that video about different consequences or different different points which you have to consider for solving a problem when a row of zeros occurred in Routh array. Okay, so watch that video and come back here so that you will understand how to solve these problems. Okay, right. So the highest power here is, first of all we have to construct the root array, so that is common. So s power 5 is the highest order, so 1, next is s cube, next is s. Coefficients are 1, 3 and 2 respectively, so I have written 1, 3 and 2, odd powers of s. Next is even powers of s. Even powers of s is 1, 3 and 2 again. Okay, so 1, 3 and 2. So s cube will be row of zeros anyhow, because when you have same rows then it will be row of zeros. So this is row of 0, right? Row of 0 occurred here. So when row of 0 occurred in odd powers of s row, that is what we have discussed, and auxiliary equation is considered in even powers of s row. Auxiliary equation is considered in even powers of s row. So what is auxiliary equation in this case? S to the power of 4 plus 3s square plus 2. S to the power of 4 plus 3s square plus 2. Okay, so what is differential auxiliary? So once you find the auxiliary equation, you have to find differential auxiliary equation. So it will be 4s cube plus 6s. Okay, so just differentiating, s power 4 differentiation is 4s cube, 3s square differentiation is 6s. Now replace the coefficients of this differential auxiliary equation, which is 4 and 6, with this row of zeros. Okay, then s power 2 is 4 into 3, 12 minus 6. 12 minus 6 is 6. 6 by 4 is 3 by 2. Similarly, 4 into 2 is 8. 0 into 1 is 0. 8 by 4 is again 2. Okay, next s power 1. S power 1 is 3 by 2 into 6, right? So 3 by 2 into 6 minus 2 into 4. 2 into 4 is 8 divided by 3 by 2. So this is 2 ones are 2 3s are 3 into 3 is 9. 9 minus 8 is 1. So 1 by 3 by 2, which is equal to 2 by 3. So this becomes now 2 by 3. Okay, this is 2 by 3. Anyhow, this is 0 because there is no element here. So 3 by 2 into 0, 0 into this is also 0. So totally 0. S power 0, 2 by 3 into 2. 2 by 3 into 2 minus 0 into this is 0. So 2 by 3 into 2 divided by 2 by 3. So you'll get 2 here. Okay, so if you observe here, row of zeros is occurred only once. Row of zeros occurred only once. Okay, row of zeros occurred only once, and there are no sign changes in the first column of Routh array. Yes or no? So there are no sign changes in the first column of Routh array. Row of 0 occurred only once and no sign changes. From the 9th point, which I have explained you in the previous video, system is marginally stable. System is marginally stable. Okay, so whenever there are row of zeros occurred only once and there are no sign changes in the first column of Routh array, then the system is said to be marginally stable. Okay, so what are the roots of this AE? AE is s power 4 plus 3s square plus 2 is equal to 0. So let s square is equal to some x. So this becomes x square plus 3x plus 2 is equal to 0. So x into x, so x square plus 2x plus x plus 2 is equal to 0. So x into x plus 2 plus 1 into x plus 2 is equal to 0. So x is equal to minus 1, x is equal to minus 2. So s square is equal to minus 1, s square is equal to minus 2. So s is equal to plus or minus j1 s is equal to plus or minus j root 2. Okay, so s is equal to plus or minus j1 and s is equal to plus or minus j root 2, right? So how will be the pole location now? So there will be poles like this. So one is at j1 and other is at minus j1. One is at j root 2 and other is at minus j root 2. So all these are symmetrical poles, yes or no? These are symmetrical poles. Why? So I have told you the order of auxiliary equation represents the number of symmetrical poles about origin. So here the order of auxiliary equation is 4. So there will be 4 poles which are symmetrical about origin, right? So 4 poles are there on imaginary axis and the remaining 1 pole will be on the left half of S-plane. Why? There are no sign changes here. If there are sign changes, then there will be poles in right half of S-plane. Since there are no sign changes in the first column of Routh array, system is marginally stable. That is, poles lies on imaginary axis. When pole lies on imaginary axis, system is said to be marginally stable. Non-repeated poles on imaginary axis, system is said to be marginally stable. And the remaining 1 pole, because total number of poles here is 5, because the highest order here is 5. So 4 poles on imaginary axis and remaining 1 pole will be on left half of S-plane and the system is said to be marginally stable. Okay, so if you can see, this is called as complete analysis, and this complete analysis we have got by studying those 10 points which I have told you in the previous video. Okay, so try to remember all those 10 points in order to have the complete analysis like this. Okay, so roots of auxiliary equation represents the poles, closed loop poles. So these are closed loop poles and they are symmetrical about origin. 4 poles symmetrical about origin and there are no sign changes below AE. So AE considered here, there are no sign changes. So there should be no symmetrical pole placed in right half of S-plane for the pole placed in left half of S-plane. That is why no pole in the right half of S-plane and no sign changes occurred. So that is why system is marginally stable. So all those 10 points are very, very important so that you can solve any problem. Okay, right, we'll see the second problem now. So the highest power here is 6. So s power 6. S power 6 coefficient is 1, 4, 5 and 2. 1, 4, 5 and 2. Similarly, s power 5, odd powers of s row. So s power 5 coefficient is 3, s cube coefficient is 6 and s coefficient is again 3. Okay, so next s power 4. S power 4 coefficient is 3 4s are 12, 12 minus 6. 12 minus 6 is 6, 6 by 3 is 2. Right, next 3 minus 5, 15. 15 minus 3, 3 into 1 is 3, so 15 and 3 5 is a 15, 3 into 1 3, so 12, 12 by 3 is 4. Next 3, this can be kept as 0, so 3 into 2, so 3 into 2 and 0 into 1, so 0 into 1 like this. Okay, so 3 into 2 like this. Okay, so 3 into 2 minus 0 into 1, so 3 2 is a 6 minus 0, 6 by 3 which is equal to 2 again. Okay, so s cube 2 into 6, 2 6 is a 12 minus 12, 12 minus 12 is 0, 0 by 2 is also 0. So 2 into 3 6 and 2 into 3 is again 6, 6 minus 6 0 by 2 which is equal to 0 again. Anyhow, this is also 0. So now 0 of row of zeros occurred here. So consider auxiliary equation here. Auxiliary equation is considered here. So what is auxiliary equation? 2s to the power of 4. Okay, so the coefficient is 2, so the coefficient of s to the power 4 is 2 plus this is the coefficient of s square, because this is even powers of s row, you will get only even powers. So 4 into s square plus 2 is equal, this is the auxiliary equation. So what is differential auxiliary equation? 8s cube plus 8s, 8s cube plus 8s. So replace this by 8 and this by 8. Replace the row of zeros by the coefficient of this. So the coefficient is 8 and the coefficient here is coefficient of S is 8 and coefficient of SQ is also 8. Now continue the Routh array. So this is 8 fours. 8 fours are 32, 8 twos are 16. 32 minus 16 is 16, divided by 8 is 2. And then 8 into 2. 8 into 2 is 16. 0 into 2 is 0. So 16 by 8 is again 2. So S power 1 is 2 8 is 16 minus 2 8 is 16. This is 0 again. And then 2 power 0 is 0. 2 into 0 is 0, and this is also 0 into 8 0. Again row of 0 occurred. Again row of 0 occurred. So we'll consider this as auxiliary equation 1. So now we are considering another auxiliary equation. This is auxiliary equation 2. Okay, so I'll consider AE1 here. So what is AE2 here? AE2 is 2s square plus 2, and differential auxiliary equation is 4s. So 2s square differential is 4s. So replace this here. So we'll get 4s here. S power 0, 4 into 2 8, 0 by 4, 8 by 4 is 2. Okay, so now the Routh array is completed. Okay, so if you observe here, the first column of Routh array, has no sign changes. So row of zeros occurred twice. 2 times it has occurred, right? So that is why we have considered two auxiliary equations, AE1 and AE2. So row of the zeros occurred twice. Therefore system, and there are no sign changes in first column of Routh array. So last point, which I have told you, 10th point in the previous video, system is unstable when row of zeros occurred more than once and there are no sign changes in the first column of Routh array. If row of then the system is said to be unstable because of repeated poles on imaginary axis. So if you find the roots here, what will be the roots? 2x square plus 4x plus 2 is equal to 0. So x square plus 2x plus 1 is equal to 0. So this becomes x plus 1 whole square is equal to 0. So then s square is equal to minus 1 and s square is equal to minus 1. So s is equal to plus or minus j1, and here also s is equal to plus or minus j1. So there will be two poles. How will be the pole location? 2 poles at j1 and 2 poles at minus j1. So this is the pole location for this problem, right? So repeated poles on imaginary axis, that is what I have written theoretically, and this is how we can show practically in this. So this becomes x plus 1 whole square is equal to 0. So x is equal to minus 1. What is x again? S square. So because I have considered s square is equal to x here, so s square is equal to minus 1, s square is equal to minus 1 again. So that is why I have got 2 poles at plus j1 and 2 poles at minus j1. So total number of poles here is 6, and there are no sign changes. Remaining 2 poles will be in left half of S plane. Okay, system is said to be unstable because of repeated poles. If the poles are repeated on imaginary axis, then the system is said to be unstable. Okay, so I have discussed this in another video also, where I have discussed the location of system output based on location of poles. Okay, you can see that video. I'm giving the link in the description, playlist link in the description. You can go to that video and watch that video as well. Okay, so this is how we can do the complete analysis of the system with row of zeros. Okay, so not only telling you how many poles in the right half of S plane, you can also comment on imaginary axis like this. Okay.